everyone, welcome back to the second lesson on variance of continuous probability distributions. So we've seen this equation last time. This time I thought a good example would be to do a triangular distribution with a lower limit of 10 and an upper limit of 70. Now you will remember that with a triangular distribution we also need to specify the location, the x value for the peak of the distribution. To keep things simple, why don't we have a peak value here at 40, which is halfway in between. So this will be a symmetrical distribution, but if we did have an asymmetric distribution, everything that we're about to do would still apply. So here's my triangular distribution. Now, as we've done in the past, we need to find the height here. The height is given by the rule 2 over b minus a. So b minus a in this case is 60. 2 over 60 is the same as 1 over 30. Now again, if you didn't remember that rule about 2 over b minus a for the height of a triangular distribution, the fundamental idea is that the area under that triangle has to equal 1. So we basically use the area of a triangle formula and solve for height. Now, we will need to define, to have formulas for our function, won't we? And I would note here that the coordinate of this point is 70, 0. This one is 40, 1 over 30, and this one is 10, 0. I'll just go off to the side here, and I'll be doing my equations of the straight lines. So for the first one, let's look at the place where x is in the domain 10 to 40. So you could write y equals mx plus c, or you could write the version of the formula y minus y1 over x minus x1 equals the gradient. I think it's quicker to do it this way. So x1 and y1, we can choose either of these points. Now I typically will choose the one where there is a 0 for the y coordinate because that makes my life easier. It's y minus 0 over x minus 10. Now what's the gradient? Well, the gradient is the rise over the run. The rise is 1 over 30, take 0, so that's 1 over 30, divided by the difference between the x's. So the difference between these is 30, so it's 1 over 30 divided by 30, and that's 1 over 900. So quickly I see that y is x minus 10 over 900. As I'm writing the formula over here for my probability density function, it'll be a piecewise equation. The first part of it is x minus 10 over 900. And that, as we said, is when x is between 10 and 40. Now let's do the next one. When x is between 40 and 70. I'll do the same version of the formula, y minus y1 over x minus x1 equals the gradient. Again, I will choose this as the x1, y1 pair because there's a 0 there. So it's y minus nothing, or y, over x minus 70. What's my gradient this time? Well, moving from left to right, this line drops by 1 over 30. So that's negative 1 over 30. And what's the run? 40 to 70 is a run of 30, so divide that by 30. I have negative 1 over 900 as the gradient. So y is, well, by the time I multiply by negative 1, it's 70 minus x over 900. And that's a nice convenient way to write the equation of that line. So let's come back here. 70 minus x over 900, and that's when x is from 40 to 70. I didn't make my brackets here quite large enough, did I? Let's do that a little bit bigger, and 0 otherwise. Now, we found last time that the mean for a symmetrical distribution, and this is symmetrical, was exactly halfway between A and B. So that value of 40 also represents the mean. However, if it was not symmetrical, we would have to calculate the mean using what we learned last time. The integral from A to B of x multiplied by px dx. Now, of course, in our case, that's going to be two integrations because we have a piecewise function. We'll integrate the first one from 10 to 40, the next one from 40 to 70. And if we did that, just like we did last time, we would determine that the mean was 40. That's not the main focus of this lesson. The main focus is variance. So let's go to our variance formula now. The variance of our continuous variable x, also known as standard deviation squared, is the integral from A to B of px, x minus the mean, squared dx. Now, our lower limit was 10, but we can only go as far as 40 using our first function, x minus 10 over 900. All of this is multiplied by x minus 40 squared dx. Then we have to add the integral from 40 to 70. Now, our probability function in that part of the domain is 70 take x over 900. Again, x minus the mean squared dx. Now, you could expand, you could multiply all of the terms, you could integrate, and then you could substitute and solve. If you were on a Tech Active exam, I would be plugging those into my calculator. When I did this, I had 75 for the first integral and 75 for the second, which is a total variance of 150. The standard deviation then, remember, variance is sigma squared, is the square root of 150, and that's approximately 12.2. So, we've seen here how to do the variance of a triangular probability distribution. I happened to choose one which was symmetric. The same processes would work if it was not symmetric, but we wouldn't be able to take the shortcut then of saying that the mean was halfway in the middle. We would have had to done this calculation here in full, just like we did last time. All right then, that's the end of this little lesson. Thanks for watching.